Hey, how's it going, everybody? It's Liv, and today we're just going to talk about inlining again. Okay, so not too long ago, I made a video about how I have a system for inlining subroutines, and I do. Now, the problem is the way that this inlining was implemented was through a source filter. Okay. So it's a source filter inheriting certain behaviors from a filter class that I wrote, which basically expects to work in a chain, okay? Because that's more or less the way that the filters work. And so, this gives you some utilities for utilizing multiple filters and stripping the use line, right, of a filter. So you have use my filter or whatever, this line will generally not be detected by your filter, but I have somehow managed to make it so it will be detected and taken away. So anyhow, this parent class gives us some cool functionality and things that make working with this multitude of filters kind of simple, okay? And what each filter does is simply it looks for a particular pattern within an accumulated string. Okay, so we are logging the entire file. We're just reading line by line, because at the time I wrote this, I didn't know you could just read the entire file. My bad. But anyhow, we could change that. But for now, no, it logs line by line and just accumulates that into a big old string, and every filter is looking for a particular pattern within that accumulated string, and just doing some substitution. So for instance, if this function right here matches the pattern of sub name inlined and some arguments, okay, and a list of arguments, plus the open curlies and and some code over here. Whenever it matches this, it will just oh no, wait, I'm sorry, I was thinking of something else. Whenever it matches something like module function name, whatever, and it has within its inner table, so this has like a table of functions that are available for inlining. Whenever it encounters any such functions, it just replaces that mention of it with a cut token, right? Which looks something like this: inline cut some number. Okay, so it just puts that in place, and then at a later date, it just replaces this. It expands this token for the proper call. Okay, so it's actually kind of simple. It's actually pretty dang simple, but it works. So yeah. Now, true to its name, this is a hack, right? So I don't just make a folder and call it hacks and put files inside of hacks without acknowledging that it is a hacky way to go about solving a problem, right? So I am self-conscious about things like that, and so I sort of felt like this needed certain improvements. And case in point, I realized that as a matter of fact, we very much do need a better solution, because what is doing the collection of these functions, so this one is not particularly a filter, but it's kind of like it. It looks for basically a subroutine, okay? Oh no, actually it is not looking for it. Sorry, my bad. What it's doing, in fact, is it's declaring give me a sec. Universal. Okay. What it's doing actually, it's declaring a code attribute. Okay, so this is an attribute that you can just slap on your subroutines, right? I'm sorry, that was too loud. But it's an attribute you can put on your subroutines, okay? And how does that work? I'm sorry, just checking that I'm recording anyhow. How does that work? Well, you write your subroutine, you write a colon, you put attribute, you can do attribute 0, attribute 1, and then a single space, and then your arguments. Like this apparently is the way it works. If you do it like this, it will assume that you are passing those arguments to the attribute itself, which I think is not a good idea. But anyhow, this is Perl syntax, okay? So this is a valid Perl. If attribute 0 through attribute n are declared, right? So they need to be imported somehow. Now, importing attributes, it's its own whole topic, and it's kind of not very well documented. So the easier way I found was to just declare the attributes as being part of universal, okay? So this is basically what you do. You say universal name of your thing, and then attribute. And in here I put code, and there are other ways you can do to. If it's expecting a scalar, it will be an attribute you can assign to a scalar, right? In this case, we want to use this for code, so it's just there for code. But anyhow, what this function goes on to do then is to do some very minimal interpretation of the Perl code, and then from that generating these little files that I can show you here. So right, so it generates these files, which are basically a symbol table, quote unquote symbol table, because it actually includes the definition. Now this is no problem, because for the most part what I'm inlining is just one-liners, right? That the way God meant, the way God intended, right? So yeah, of course. But if you had a larger, code, it would just it will make the line wrap around, which is not so nice. But yeah, like whatever. So this is okay, and it's actually kind of really easy to read, right? Because you know that the name of the subroutine is the first line. The second one is for state variables. The third one is for the argument, and the fourth one is the code itself. And then it's just textual substitution of any mentions of the name by the code, and any mentions of the arguments within the code with the arguments that the user has provided. So if you call this function, but you don't pass b, say you pass x, well, simply we know that x is the first argument, and thus its counterpart within the definition is b. And so all we have to do is replace all mentions of b with x, and that's that basically. So yeah, it's actually not utterly complex. It's just hacked together, right? So that's what I mean with a hack. It's not a very straightforward solution, first and foremost, and it's just sort of pieced together, right? And here's another thing. In order to get the code through an attribute, in order to get the code through the attribute, what we are doing is we're using this little function from the dparser, right? So we are calling bdparse. Let me just write it for you. So bdparse, we are creating a new instance of the dparser. And the dparser, having been passed a code reference, can give you the a close approximate of what the code for that is, but actually not really. So see, BD parse will give you a version of your code after having been processed, right? So for instance, suppose you have a constants, and constants not made with read only, but rather constant made with the use constant pragma. So now you have read only. Oops. You have read only, and in read only you declare as such name value, right? And with the constant pragma you declare like so, constant name value, right? So any constants you have, the parser will give you them already substituted, right? So if your constant, the value of your constant was 5, wherever the name of your constant was, you would have 5. Even if that was not what you meant to happen, you know, like it's not really a problem, but you know, it does things like that. And it will at some points just change your code ever so slightly. You know, just do little optimizations and things like that, and put in the error messages and that kind of thing, which is fine, right? But yeah, it does come with some problems. See, in this symbol table that I showed you, the only way I could make it so this line was pasted exactly as it is was well, I actually had to add a return in here. Okay, so in the source code, let me just open that up. If I go to this query, you see we have a return, because if I remove this, then this line will become it will turn into this, which is no good for inlining. If you want to inline this, well, imagine, you know, if you are doing it within a plain line, right, as a plain expression, so being called by itself, it's fine. But this is a function that most of the time you would be calling within an if, or within a conditional, for either a while or a plain if or else if. So if you do this, what you will get is a syntax error, you know, rightfully so. And yeah, you know, like the deparser will make changes like that to your code without your consent. Right? And so yeah, it's not the best fit for this, actually. The way I think about this is I don't really want to be using return. Like, I don't really want to be using return. Like, you know, if you want to use it, that's fine. But for something that you are expecting will be pasted in the line, within the line where it is called, yeah, like I would prefer it if it were not modified, right? So this is no good. Okay, that's what I'm trying to get at. This whole using the deparser is it's not good. It's you know, it's okay for a minimal for a very minimal set of use cases, you know, for trying to get the code, but when you're trying to process the code and then have it be compiled, right? Yeah, for a preprocessor like what I'm writing, it's not so good. It's actually not so good. So I have a solution, right? So you know me. I don't just present a problem and no solution. I present the problem and then the hack I came up with to solve it. So anyhow, as you might have picked up on, I've been writing a new parser, okay? And this parser does not go line by line. It reads the entire file in one go, and it's actually pretty damn fast at it. It's amazing. It's frankly amazing. But anyhow, the way it works is, and yeah, the constructor for the new parser is called new parser. Can you believe that? Anyhow, my ears were ringing there for a minute. The way it works, you pass it the language you want to be working with. And give me a second, yeah. The music is too loud. I love that soundtrack, but the music is too loud. Anyhow, you pass it the language you're trying to work with, you know, and you need to have your language definition for that language loaded in. And you pass it the name of a file, right? And it will create a sort of parse tree. Let me just show you the tree as it is. I believe I've already done this before, but okay, just to show you. Let's go there. Wait, I need to go into Automat. What? Yeah, give me wait, give me a second. Okay, so that was not supposed to happen. That was not supposed to happen, but alright, I'm game. I suppose I need to do a change there, yeah. Huh. I shouldn't have to. Wait up. Your actual and 500. So what's that code fold? Okay, so it cannot find the file, but the file is oh. Okay, so that explains things. All right, there we go. I got confused. I'm sorry. Okay. As you can see, it gives us a half parse tree, right? So you know you'll be wondering what are these cut tokens? Well, basically they are just abstracting away certain elements, but whatever was where whatever used to be where this token now stands is actually saved somewhere else, right? So like you do with a string literal, right? So generally when you're parsing, because you want to cut certain spaces and modify certain things, say you want to strip comments and things like that, but you do not want to strip a comment if it is within a string, right? You don't want to do that. You don't want to touch the strings. The strings are data. They should be left as they are. And so what they do with a string literal is you just, once you find the string literal, you just replace it with something else, with a placeholder token, right? And you say, this is a string. We'll deal with it later, right? And so basically I've done the same, but for a lot more things. I just put in a token and say whenever the user is ready to expand this, they can expand this, okay? And so that is a little bit of part of why this is so fast, because we don't recurse if we do not need to, right? So that's a little bit of the beauty of it. Anyhow, so you can see this gives us a list of our subroutines within a given file. Now there is a way to do a little bit of sorting of this hierarchically according to packages, and this one is dependent on your language definition. So here we're working with Perl, so let me just show you. right? So we have our higher sort function, right? And we just assign it straight up, and then the parser will call this whenever you call higher sort, right? So it's just, you know, it's just an alias, or no, not an alias, a shorthand, right? It's just a shorthand for making this call, just to have a little bit nicer syntax. And well, basically what this does is it will take whatever is within a package and make it a child of it. And what does that look like? Let's take a look. What I'm going to do is I'm going to limit the depth of this. Okay, so it will only print the first children, the first row of children. And you see we have two packages, lang and lang definitions, which is sort of the base class for all language definitions. And it's an integral part of the parser. If we go to one level deeper, we start seeing all of the use and read-onlys and whatnot. And well, if we just delete this, we'll get the full thing. Okay. So, all right, what can we do with this? Well, for every subroutine, we have a tree, a tree on itself, right? So in here, all we have is the ID, but the ID is all we need to fetch the block containing all of the subroutine data. So let's do that. And I've already done it, of course. Let's just get rid of the print in here. And what we're going to do is we're going to find, first and foremost, the package lang, right? So you remember that I show you that at the very top, the only two children of the root of the program is the two packages, right? And then through the packages we can access the subroutines. Okay, so we select a package, and then the children of that package, within that array of children, we can find our subroutines. Okay, and so we do that. We say branches within package that contain the keyword subroutine. Easy enough, right? And so then we just walk through those subroutines, find the value of the first leaf of the node, right? Which as we can see here, so this is the subroutine node, right? So this is what we would get with this function call. It returns us an array having all of these nodes that contain the keyword sub. And the first child, the first leaf of any subroutine node is just the subroutine ID, right? So we take that and we take that ID and we just tell the parser to give us the block matching that ID. And that gives us basically the subroutine. And then we can access the subroutine attributes. All right. So let's see what the subroutine attributes are. And, you know, just spoiler alert, the only subroutines with attributes are the ones I've marked as inline, right? So right now, this would work just fine for our current purpose. But we can use this to do preprocessing of any kind of subroutine attribute that we might be able to come up with. Kind of nice, isn't it? So okay, we want to suppose print out the attributes just because it's fine, because it's fun. We'll just print that out, and then we'll just actually I'm not going to recurse. I'm just going to show you the block as it is. Okay, and we're not going to do it for the entire thing. Okay, that's fine. Okay, and so you see this is actually pretty simplistic, and it's the same thing we had before, right? So we have some keywords, and then at every turn we have one of these cut patterns, tokens, right? And it's the same idea. We have something between parentheses we don't want to really mess with that until we really want to. Okay, so if we call the recurse function, we'll be doing just that, right? So the recurse will just take a tree, or a branch of a tree, and whenever it finds these tokens, it will expand them, and it will do so recursively. And so now, excuse me, okay. And so now we have we have the code. We just parsed it right out of the source file. So not that difficult. And as promised, the only code attribute present within the file is inline. Like, you already knew this probably. I just told you. But yeah, we could use this in order to to create any kind of code attribute that is meant for preprocessing, right? So this is not something that comes into effect at runtime. That is the key. That is the key thing here. These kinds of attributes would not come into effect at runtime. Okay, so this is something. What we are doing is we are modifying the code, okay, during a sort of a preprocessing step or precompile step, if you will, and then we output a modified version of the original code. And within that modified version, we can have all sorts of crazy things. So, for instance, we can have it so a mention of a given function is replaced by the code of the function itself. So that's kind of nice. Now, caveats, I think it's pronounced. Currently, this doesn't really work if you have something like object and method, right? Or if I can write a method, like this doesn't really work for now, right? So the only way it works right now is if you have a module colon method, right? So this thing works. This will be inserted right away. The other form is more complex because a call, like suppose you have object method, and suppose you pass it some arguments, and then from the return of that method you call another one, like get me something, right? Like suppose this is a getter of sorts and it gets you something else, right? And from that which you get, you are calling another method. It's not really good practice, but it is something that it's so ubiquitous. I'm sorry, I'm not entirely sure how to pronounce that one. Ubiquitous, I think it is. It's present everywhere, okay? It is something I see so often, not just in my own code, but in other people's code as well, that I think that not supporting this kind of syntax, it's a bad idea. Like it's just something people do, It is bad practice, but we do it. It is bad practice, but we do it. And if you wonder why it is considered bad practice, it is because you are making it so a single piece of code knows like the entire pathway. Okay, so what do I mean by pathway is the sequence of calls that need to be made, right? So the precise sequence of calls that need to be made in order to get a particular piece of data. So that means that suppose that this is within a function, right? So this line is within a function, and you're doing something like not 2, but about 3 or 4 consecutive calls, right? Basically what you're doing is you are in a sense embedding into that function too much information about the the data structure, right? So basically you are punching through the encapsulation of multiple classes within a single function. So generally, it, at least in the realm of programming theory, it is considered bad practice. But the thing is, it's the natural way to code, okay? Like I understand the reasoning, but I could have never put it into practice, because at some point you need to access the data. It's just like the object-oriented theory mongers would have you never access the data, because that punches through the encapsulation, right? Like, never access the data, and then your encapsulation is perfect and you have no coupling, right? But you cannot do anything with the data, so why do you even want it in the first place? It's just so stupid, so stupid. And those people later, they write books and they give talks and they go into Amsterdam and talk to the high society, right? Guys that have done nothing with their lives but write, I don't know, fucking web pages and right, fucking web pages that they can't load your font properly, and if you use a font size that's slightly larger than what they expect, the entire fucking site breaks, right? And those guys make millions and millions and millions, and I am here in my mama's basement. Yeah, that got too real too quick. Anyhow. Anyhow, even the entire criticism of society aside, that entire thing aside, I understand that theoretically, in the realm of pure programming theory, this this form should not be supported. But I understand as well that in the realm of programming practice, that means we, the guys that write, code for real, and not just, write books and give talks. Yeah, like this kind of pattern is something that once or twice you're going to have to do at some point. Because, if you don't do it like this in a single line, you're just spreading it out across multiple functions, which is essentially the same. You're just giving the illusion that you are not punching through the encapsulation while you are still punching through the encapsulation. So it's the same thing. It's the same thing. It's just, more psychologically satisfying. No, I think the straight up way to do it is the better one. And so the straight up way to do it should be the one that I'm more interested in supporting. But it does, a few complications do come about here, right? Because well, first and foremost, you do have to know what the class of object is, okay? And in other programming languages, this would not be that much of a problem because you have types. But in Perl, we don't really have types. We have sigils, right? So sigils sort of inform what the context of the call is, right? Well, it's more in depth than that, but just to give you the in and out of it. The sigil basically tells you in which context the call is being made, or I suppose you could say what kind of thing a name is. That is also valid, I guess. But in any case, and the sigil doesn't really tell you, is this a string? Is this a number? Is this a reference? It doesn't really tell you that, right? So this is a scalar, right? And a reference is a valid scalar, right? A hash reference is a valid scalar. An array reference is a valid scalar, right? A regex, right? A compiled regex is a valid scalar, right? So what do? Well, I'm not sure how I'm going to solve the problem yet. I have a little bit of an idea of how I could solve it, but I'm not entirely sure how I'm going to implement it. So for instance, suppose I could say my object, and with the same attribute, syntax, which interestingly enough, it's how you do types in Python. I think they call them annotations, right? So for instance, in Python you can write it like this, and you're saying basically, actually, in Python you would write it like this, right? So some value, right? And so basically we'll be saying, I pinky promise. It's basically that I pinky promise that I will only use this variable for integers, right? So and nothing else, right? So that's basically what it's doing there. Well, we could do something kind of like this, but suppose we say we just pass it the name of the class, for instance, right? If we could, like, I don't know, my class subclass, say, something like that. Now, this will not be in standard Perl syntax. Having these two here would not be a valid separator, but because we are doing pre-processing, I can just replace this for whatever, or just just empty it altogether, and it will be no problem, right? So yeah, we can do something like that, and that will be fine. Though generally I would prefer this. We can do that, but the thing is, it would mean we have to, to make sort of like a symbol table for those kinds of variables as well. And so then, when we encounter object and the method call, right? We know that we need to check the method, the symbol table for my class, right? If we do not have this, then first and foremost, we do not know what symbol table to consult in order to, check if the method is even marked for inlining, right? So, yeah, kind of complicated, isn't it? So yeah, that is an overview of the new problems that have arisen as of late, and yeah, I suppose I'll be working to try and solve that. I mean, for the immediate problem is just replacing the entire inlining mambo with just this thing. We just read a file, find all of the functions marked for inlining, build a symbol table, and that's that basically. Then we just replace things in place in any subsequent files that we read. Okay, so that's not all that complicated. It really isn't. But well, then taking that to work with classes and the like, in order to do what I showed you with the calling the method from the object. Yes, that is going to take a couple more steps, but God willing, we'll be able to. So yeah, that's basically that, and that's it from me. So have a good one. Bye.